Hello and welcome back to the Rice Robotics Club Robo-Tutorial. In this video, now that we've CAD'd all of our individual parts, we're ready to start putting them together into an assembly. Now I have all of our parts here, and we could just put them in all into one big assembly all at once, but instead we'll be taking an approach where we take our parts, put them into several sub-assemblies, and then put those sub-assemblies together into what we'll call the top level assembly. And putting it together in this way allows it to be edited more simply because you don't have a long list of mates. You instead have several sub-assemblies. And if you need to edit a certain component of the top level assembly, you just open up the sub-assembly and go make that change. So it may not make much sense right now, but just know that that's going to be our approach. So we're going to start in this video by creating a sub-assembly between the pulley and this servo horn here. We're starting out small. So we're going to go back to our Onshape document. Before we create our assembly, you'll see down here in the file select, it's getting a little bit messy. We have lots of parts, which has been fine up until now. But as we start adding assemblies in, we will also want to have this file select be a little bit more organized so it's easier to navigate. So in the file select, hit this plus sign. We're going to create a folder. And in this folder, we're going to hold all of our individually CAD'd parts here. Okay, we're going to call this parts. And then drag each of these parts into the folder. And organizing our files in this way is just going to simplify navigating and allow us to more easily find and edit the parts that we need to make changes to. Okay, and now we'll hit the plus sign again and we'll create a new folder. And this folder is going to be our sub-assembly folder. So we're going to be creating several sub-assemblies in the next few videos, and this is where we'll store them as we go. So all the way from back whenever we first created our Onshape document, it automatically created this blank assembly studio. So this is where we'll be creating our first subassembly. That's going to be between, like I already mentioned, it's going to be between our pulley and the associated servo horn. Okay, so this is the assembly. It looks very similar to the part studio. It has a workspace. It has some controls to orient the view up in the top right. Over here, you have a feature tree. It'll function very similar to how the feature tree worked in the Part Studio, but in this case, it will hold a few different kinds of features. Mostly, the parts that you import will be shown up here, and down here, it'll show all of the mates that you add. So a mate is sort of like a relation that you add between two parts that constrains them in some way. So to fully define an assembly, it's very similar to fully defining a sketch. So whenever you're working in a sketch, you fully define it by adding a series of relations so that the orientation and size of all of your shapes that you've drawn are fully defined. In the case of an assembly, you've already created the parts, so now you need to add mates that make sure that the position of all of those parts relative to one another is fully defined. So that's how it's going to work. It'll get a little bit clearer as we start going through it. So we're going to start our assembly by adding in some parts. So this is the assembly toolbar. We'll start by inserting our pulley that we CAD'd earlier. So whenever you hit insert, it opens up this dialog where it shows all parts that are stored in this document. So we'll add the pulley. And now we need to import our servo horn from the provided CAD files before we're ready to continue with this assembly. So we'll go to the bottom left. We're going to select import. Navigate to the folder containing the files that we've given you and import the servo horn part. Accept all the defaults here. And now we'll wait for it to import and then we'll drop it into our parts file before continuing with the assembly. Here's the servo horn part. It looks like we expect, so we're going to drop that into our parts folder. Go back to our assembly, hit insert again, scroll down, and now you see this servo horn is included as an option. So click the servo horn, drag out, click again to place it, hit the green check mark, and now we're ready to start our assembly. So by default, if you grab one of these parts, it can move freely. It can move to anywhere in the workspace. It can also rotate freely because there are currently no constraints, no mates applied to either of these parts. Okay, so to start constraining our assembly, we'll start by adding a fastened mate. So a fastened mate locks two parts together and then removes all translational and rotational degrees of freedom between those two parts. So by default, each of these parts has 6 degrees of freedom, okay? It can translate along 3 axes. It can translate in the Z direction, the X direction, and the Y direction. And it can also rotate along any of those axes. So whenever you have no mates applied, a body has 6 degrees of freedom. Whenever we apply this fastened mate, it's going to remove all 6 degrees at once. Okay? So we're going to start by applying a fastened mate between the pulley here and the assembly origin. Okay, so we're going to add our first fastened mate, and it's going to be between the pulley and the assembly origin. So select fastened mate. Select the side of the pulley that doesn't have the servo horn cut out. In this case, it's going to be this face. And you'll see a little coordinate system show up at the center of this surface. That's what's called a mate connector. And the orientation and position of that mate connector is what describes how our mates will behave inside of an assembly. So in this case, just make sure that this mate connector is lying at the center of this circular face. And it adds a mate connector to this mate dialog. And then we'll add the other mate connector to the assembly origin here. You'll see those two snap into place. So this is almost what we want, but we do want this servo horn slot to be facing upward for the next step. So hit the flip primary axis, and it will flip the orientation of that mate. And now hit the green check mark to finalize the mate. And you'll see the dialog box automatically opens to create another fastened mate, which is actually what we want. Our next mate will be a fastened mate between the servo horn and the pulley. Before we get to that, click and drag this pulley. You'll see that it can't move or rotate now that it's fastened to the origin. That's because we've removed all 6 degrees of freedom of that pulley by fastening it to the origin. So our next fastened mate will be between the servo horn and the pulley. So our first mate connector should be on this front face of the servo horn, and it should be at the center. If you click on the front face, it's going to try and place that mate connector at a bunch of other positions. But if you select this circular edge, it'll place it right at the center, which is exactly where we need it to be. So we have a mate connector at the center of this face. Then we need another mate connector at the center of this cutout, which should be right there. And the reason why it's important that these be at the center is because once you create a mate, fastened mate between these mate connectors, they're going to be put at the same position. So if our mate connector on the servo horn is in the incorrect position, then the mate won't behave like how we want it. Now, this is a mess, right? The servo horn is totally phasing inside of the pulley. That's because it's oriented in reverse. So hit that flip primary axis button again. And now it looks like as we expect. And now the front servo horn face is fastened to the pulley, and that's more realistic behavior. So this is our first subassembly. It's now complete. It just shows how the servo horn connects to the pulley. And in a later step, we'll actually connect this servo horn to the servo that will spin it. And that will be one of the degrees of freedom of our robot arm. So that'll make more sense once we get to the top level assembly. But for now, that's the end of this subassembly. So make sure to name your assembly before moving on. And then make sure to drop your subassembly into the subassembly folder, and it's complete. So now we'll move on to the next subassembly.